Hello. In this video, I will do some reconstitution practice problems. So this is concentration, reconstitution, and dilution, and this section will be on reconstitution. Okay, so let's begin. So in example one, you have an order of as I can't really read this word, but I'll try my best. Azithromycin, 80 milligrams PO daily. The reconstitution instruction says tap the bottle of loosened powder, add 9 milliliters of tap water to the bottle, or a concentration of 100 milligrams per 5 milliliters. Bottle contains 300 milligrams, 15 milliliters when mixed. So this is definitely a reconstitution because we're adding a diluent or a liquid to a powder, right? And what the question part A says, how many milliliters should be administered per dose? Round to the nearest 10. So we could definitely do this on three ways, dimensional, um, ratio and proportion and formula. So when they, so they're going to give you information that you may or may not need. So just look at the question. It says how many milliliters? So that means our final answer shall be in milliliters. So the first thing I would first check when we're doing dimensional analysis is check if we have to do a double conversion. Let's see. We started out with 9 milliliters, right? I mean, what? No, 80 milliliters. Yes, we started out with 80 milliliters. Our final unit has to be in milliliters, and we have a concentration of 100 milligrams per 5 milliliters. Okay, so I don't think we need to do an extra conversion because we have it. We start with milligrams, and then our concentration is 100 milligrams per 5 milliliters. This one right here. Uh, we don't need to worry about the add 9 milliliters tap water. That's yeah. So let's start with dimensional analysis. So we started out with 80 milligrams of what? PO. So milligrams, 80 milligrams, fraction, and then our final units has to be how many milliliters? Final units has to be in milliliters, right? Now look what we have. We have a concentration of 100 milligrams per 5 milliliters, right? And should we leave it like this? No, we should not. We have to flip it. Now, if you flip it, does it change this concentration? No. You can do that. You can also say 5 milliliters or 1,000 milligrams, 100 milligrams, right? And we want it like this. Why? Is because we want to get rid of the milligrams. So I'm going to put milligrams on the bottom and milliliters on the top. So for 5 milliliters, there's 100 milligrams. This is perfect because the milligrams disappear and you're left with the final units, milliliters. Sometimes you gotta flip it. That doesn't change your concentration, right? So go ahead and multiply it out. So when you're multiplying fractions, you multiply cross. So it'd be 80 times 5 over 1 times 100, right? 80 times 5 is 400. And then 1 times 100 is 100. And then the zeros cancel, so you're left with 4 milliliters. Okay, and it says round to the nearest tenths. 4 milliliters is fine. You don't have to say 4.0. This is perfectly fine. Okay, now let's say solve the same problem using ratio and proportion. So yeah. So we write it as a fraction and our units, I believe our units should be in milligrams per milliliters. Excuse me. And then if you want to do that, that means that this side should also be in milligrams per milliliters, right? So we started out with 80 milligrams. We want to know how milliliters, so that'll be our unknown. And then we were given 100 milligrams for 5 milliliters, right? Okay. And then all you got to do is cross multiply. So let's get 5 times 80. That's 5 times 80 equals x times 100. And then solve for x, you're going to divide this by 100. And you get 5 times 80 over 100. And you get 4 milliliters. Okay. Now let's do the same. Let's find your answer using the formula method. So for the formula method, you do have desire over half times vehicle. Okay. So make sure the desire and have are the same units, which they are. They're both in milligrams. So our desire was 80 milligrams, right? We want to know how many milliliters. Yeah. And then we were given 100 milligrams times by our vehicle, which was 5 milliliters. As you can see, the milligrams disappears, and then uh, you can just multiply across, not crisscross, but across, so 80 times 5 over 100, and you get 4 milliliters. Okay. Okay, now let's do the part B. There is a part B. So part B says, how many full doses are in the bottle? Yeah, so how many full doses are in the bottle? So if you recall, it said there were in this problems, the bottle contained 300 milligrams or 15 milliliters when mixed. So there are 15 milliliters in each bottle. Each dose we are giving 4 milliliters. So there are 15 milliliters in a bottle, and each dose we're giving 4 milliliters, right? That was the answer from part A. So what's basically 15 milliliters divided by 4 milliliters, which is 3.75 milliliters. But we cannot give 3.7 dose, right? So sometimes you have to round to the, yeah, we cannot give 3.75 dose, but we can give 3. If we give 4, that'd be an overdose, right? So I think it's just good to just start with 3 full doses. So, but we can 3 full dose. So that would be your final answer. 3 full dose is what we can give. Okay, so that was concentration, reconstitution, and dilution. And this is a reconstitution problem because we're adding a diluent to a powder, right? So yeah. And then I think the next one will be a dilution where you add water to another liquid, right? So yeah, we're gonna stop here.